All right, next in the unit, we're going to be adding and subtracting rational expressions, which means we'll be adding and subtracting fractions. And so what we're going to do before we start doing that is just a little review of how you actually add fractions. So the first thing on your note says, what does adding and subtracting fractions actually look like? And we're going to go ahead and draw pictures because there's a common mistake that is made that would probably not be made if you were thinking about the picture. So we're going to go ahead and divide that square into 2/12. And the first square is going to be 1/12. So of the 12 pieces, you will just shade in one of them. And then we'll go ahead and draw another square with 12 pieces. Guess I'll divide that more evenly. There we go. And this one is going to be 5/12. So I'll color in 5 pieces. And if I were to add those together, then hopefully you'll see that if I have 1/12 colored in and 5/12 colored in, then I should color in 6 of them to see what the sum actually is. So when I add these together, just kidding, put the equal sign up here, add those together, that equals 6/12. Now, the common mistake that a lot of students make is they would say 1/12 plus 5/12 equals 6/24. And if you can see from the pictures that we have, that's clearly not the answer. It would be 6/12. If you were to draw 6/24, then it would look like this. There's 12, so I'll divide each of those in 2. Now I've got 24 pieces, and it'd just be 6 of those 24 pieces. 3, 4, 5, 6. And you can see that that is not the same as that. So that's a common mistake that students make. You just have to make sure that you have a denominator, and then once you have a common denominator, the denominator will stay the same in the final answer. You do not add the denominator together. You only add or subtract the numerator. So next, on your notes it says, how do I find a common denominator? Well, first I'm going to write an example. So 1/15 plus 8/24. So what we're going to do is we're going to factor the denominator so that we can figure out how many pieces the denominator has. So factor the denominator. So 15 is 3 times 5, so that would be like the factors of 15. 24 you could write as 3 times 8, but 8 can be broken down further. 8 is the same thing as 2 times 4. 4 can be broken down further. That's the same as 2 times 2. So if I wanted to write down the very smallest factors of 24, I would say that's 3 times 2 times 2 times 2. So I know that when I write my common denominator, I have to have pieces that will hit all of those. So my common denominator here for sure needs to have a 3 because both of those denominators have 3's in them. To match up with the 24, it's going to need to have 3 2's because I have to be able to use all of them. So 1, 2, 3, so they're all used. And then it also needs a 5 for the 15. So my common denominator here is 3 times 2 times 2 times 2 times 5, which is 120. That is my common denominator. So factor the common denominator, and you might add more to that so you can see all of the pieces you need. Pieces you need. And then once you know the pieces you need, then you just make sure that your common denominator has all of them. So if I wanted to go through and finish adding this, 1/15 plus 8/24, I'll notice that the 15 has the 3 and the 5, but it's missing the 3 2's. So 2 times 2 times 2 is 8, so it's actually missing 8. So I'm going to go through on this fraction and multiply the top by 8 and the bottom by 8. 24 had the 3 and the 2 and the 2 and the 2, but it was missing the 5. So I'm going to have to go through, and that fraction on the right, I'm going to multiply by 5 on the top and the bottom. So what we will notice now is that first fraction is 8/120. The second fraction is now 40 over 120. And when I add those together, I just have 48 over 120. And of course, we always want to simplify if possible. So I was being lazy. I went ahead and plugged 48 divided by 120 in my calculator. It was a decimal that I changed back into a fraction, and so I know it simplifies to 2/5. All right, next, your notes say, what if there's a variable? So for example, if we're looking at 1 over 5x plus 1 over 6x squared, we're going to do the same thing. We're going to factor it out. So 5 and x is 5 times x. 6 times x squared is 2 times 3 times x times x. So for my common denominator, I need a 5, I need a 2, I need a 3, and then I need 1x for sure because each of them have 1x, but the right fraction has one more x, so I need another one. So my common denominator here is 5 times 2 times 3, which is 30, and 2 x's, which is x squared. So that is my common denominator. So if I was to go back through and actually calculate this problem, you will notice that the first fraction has the 5 and the x, so I've got the 5 and 1x, but what I'm missing is 2 times 3 and another x. So what is missing from that is 6x. So I'm going to multiply by 6x on the top and 6x on the bottom. On the other fraction, I have a 2, a 3, an x, and an x. What I'm missing there is a 5, so I'm going to multiply the top and the bottom by 5. So now that first fraction is 6x over 30x squared. The second fraction is 5 over 30x squared. And I'm going to write my final answer as 6x plus 5 divided by 30x squared. So that when I added those, I made them into one rational expression, or one fraction, I guess you could say.